Hi, this is Mrs. Often, and in this video, we're going to be looking at special segments and points in triangles, looking at some examples where we use properties of the perpendicular bisector, angle bisector, median, and altitudes of triangles. So in this diagram, we are given three segments that are the perpendicular bisectors of triangle ABC, and we're asked to find the length of the segment GC. So something to remember about perpendicular bisectors is that perpendicular bisectors intersect at the circumcenter of the triangle, and that circumcenter is equidistant from all the vertices of the triangle. So we're given that BG has a length of 13.4, and therefore GC and GA must both have a length of 13.4. And again, that's the circumcenter theorem. And by substitution, we get our answer. Here we go. In this diagram, you try. Find the value of JZ. Again, Z is the circumcenter. Well, hopefully you've used the circumcenter theorem, recognizing that Z is equidistant from the vertices of triangle GHJ. You haven't been tempted away by all of those other great decimal values. We see that JZ must be equal to GZ, and by substitution, JZ is equal to 19.9. By the way, HZ is also equal to that. In this problem, we'll use some angle bisectors. You'll notice that we have LMN. The distance from P to MN must be the same as the distance from P to LM. So we see this segment 5, and even though it looks kind of tiny, that's just an artifact of the way this figure is drawn. This distance here is also going to be 5 in length. Finally, the distance from P to LN is also 5, and that point P is our incenter. More properties of angle bisectors here. QX and RX are angle bisectors in triangle PQR. We're asked to find the measure of angle PQX. Okay, angle PQX. So we're going to use the triangle angle sum theorem, and we're also going to use some properties of angle bisectors. So you'll notice that RX has bisected angle QRP, and that QPR has not been bisected. It has a measure of 52 degrees. So we're going to do some substitution. A whole lot of stuff just popped up here. Walking through this, QRY is going to be equal to 2 times the measure of XRY. So that's going to be 24 degrees. By the triangle angle sum theorem, all of the angles in here, this is 24 degrees, and here at PQR must add to 180. So I have my 24 degrees, my 52 degrees, and so the measure of PQR is going to be 104 degrees. Now, what's important is that I'm really looking for PQX, and that's this angle here. So if I know that the whole thing is 104 degrees, well, I'm just going to multiply that by 1/2 or divide by 2 to get my final answer, that the measure of PQX is 52 degrees. Now you may be asking yourself, hey, what's going on here? It looks like this triangle adds up to more than 180 degrees. If I erase a little bit, you can see that this is not actually a straight line, and this is a quadrilateral PQXY. So that's not actually a triangle. It is okay for PQX to be 52 degrees. An application here. We have a city planner who wants to build a new library that's between a school, a post office, and a hospital. We want to draw a sketch to show where the library should be placed so it's the same distance from all three buildings. In your project, their PBA for this unit, you will be thinking about this in terms of placing a grocery store so that it is equally accessible to all members in a community. So if we think about this, we have the school, the post office, and the hospital. They're going to be vertices of the triangle. So the circumcenter is going to be equidistant from the vertices. So circumcenter, equidistant from the vertices, that is going to be perpendicular bisectors. So I'm going to want to construct perpendicular bisectors so that they're all equidistant and I have the correct location. So we're going to draw the triangle formed by the three buildings, construct the perpendicular bisectors of each side, and the position for the library is the circumcenter. So there it is. We have post office, school, and hospital, and right there in the middle, that would be the best location for the library. Now, in a slightly different approach to things, a city wants to build a firefighters monument in the park between three streets. Here, we want the city to place a monument so that it is the same distance from all three streets. It's not going to be the same distance from all corners, but it's going to be from the sides. So in this case, we want to use the angle bisectors and the incenter. So we're going to draw the triangle formed by the streets. There it is. And we're going to draw the angle bisectors. And I'm going to do a terrible job of drawing these angle bisectors. There's another one. There's a third one. And right about here, there's that incenter. It is going to be equidistant from the streets. So that is where the city should place that monument at point M. And there it is, sketched out a little bit better. So you can see I didn't do too bad a job, but it will be equidistant from the streets rather than being equidistant from the corners of the streets. Moving on to the centroid, here we see we have a centroid because our segments are connecting vertices to midpoints of opposite sides, so we know that point S is the centroid. Well, it tells us RL is 21 and SQ is 4. We need to find the length of LS. So here's LS. Now RL is 21, SQ is 4. We really don't need anything to do with SQ. What we need is that RL is 21. And by the centroid theorem, LS equals 2/3 of RL, because LS is the segment going from the vertex to the centroid. So if I find 2/3 of 21, I'm going to get that LS is equal to 14 units. And we'll see this worked out again. Now, if I want to find SQ instead, or if I want to find NQ, I'm sorry, right here, I have NQ. Well, I know that SQ, this little bit down here, is 4. So 4 is actually 1/3 of NQ. So since NS plus SQ is equal to NQ, I know that NS equals 2/3 of NQ. Well, that tells me that SQ is equal to 1/3 of NQ. So 4 is equal to 1/3 of NQ, and thus NQ is equal to 12 units. So there's our work done in the format of a 2-column proof. Okay, our quick check. Please just stop the video for a moment here and make sure that you get the correct answers. In triangle ABC, AE is equal to 12, DG is equal to 7, and BG is equal to 9. And you're asked to find each length. So please go ahead and pause for a moment so you can determine those values. And we'll see here, AG is 2/3 of 12, or 8. GC is twice the length of DG, or 14. And GF is half the length of BG, or 4.5.